Good morning, our class. Hope everyone is doing well. And this is the second part of the home learning on algebraic equations and how we can solve them. So yesterday we started to look at using a bar model to solve an equation like this, 4t plus 2 equals 18. And we could do it by representing it as a bar model with our 4t's and the 2 meaning 18. So therefore we could take away the 2 from both sides, meaning that 4t was 18 take away 2 was 16, and therefore 1t, 1/4 of 16, or 16 divided by 4, t was 4. And that is a way that you can always use, and that's the thing now with maths. If that is a method that really works for you, absolutely brilliant. Quite a few of you got in contact yesterday to say that it was a useful method, but one thing people found was that actually it slowed them down, and I completely agree. This is a method to represent how the equations work, but what we want to do is get to a stage where we don't need to be drawing bars for the rest of our lives, because to solve this one equation, that's a lot of writing and a lot of working out to do to come to this answer. So today we are going to be looking at being able to solve these equations without needing to use a bar model. So if we have a look at this first one here, we've got 3f plus 2 equals 17. And before, we would be drawing this out into the different bars, but what we're now going to do, we're going to look at it as if it's a story, and it's telling us what happens to f along the way. So on the way, the first thing that happens is 3f means it has been times together by 3. And then, as it goes on, we've then added the 2 onto it to the end get to 17. Now what we are doing, and this is what we did with the bar model, is we're now undoing it on the way back by doing the inverse, so doing the opposite. So the last thing we did to f was to add 2. So the first thing we're going to do is the opposite of that. We're going to take away that 2 from the 17, our answer, so we are now up to 15. So we now know that 3f equals 15. But we don't want 3f, we only want to know what f equals. So therefore, we can go 3 times f, the opposite of that is dividing, so how many 3's go into 15, or 15 divided by 3. Either way round, we're going to know that 1f is going to make 5. So the answer I'm looking for here is that f equals 5. Now, I want to be able to test that, so I think f equals 5, so let's have a look. 3f, 3 times 5 is 15, add the 2, 17. So I'm pretty confident that f is going to equal 5. Have a look at this second one in here. We've got 5m plus 6 equals 41. Exactly the same, so have a think on the way. We times m by 5, that was the first thing we did, and then we added the 6 to get 41. So on the way back, we're going to do the opposite. The last thing we did was to add 6, so we want to take away that 6. 41, take away the 6, is going to leave 35. So I know that 5m is 35. But again, I only want 1m. So to find 1m, I need to do the opposite of timesing, which is dividing. 5 lots of m was 35, so I will need to find 1/5 of it, or 35 divided by 5. I know that 5 7's are 35, so I'm fairly sure that m is going to equal 7. And again, let's just test it. 5m, so 5 times 7 is 35, add 6 is 41, m is going to equal 7. And the only thing that's different with this are that the numbers are slightly larger, but it's the exact same principle. On the way, 8k, so we've timesed, add 23 is going to be 127. So on the way back, we're going to do our opposite. We added 23, so now we're going to subtract that 23. 127, take away 23. And if I'm not sure, don't forget we can use our subtraction written method. Does leave me with 104. I'm now then saying how many 8's go into 104, because I've times it by 8, so now I need to divide it, or I've got 104 and I need to split it into 8 to find just 1k. 8's into 1 doesn't go. 8's into 10 goes once with 2 left over. 8s into 24 goes 3 times. Therefore, k must equal 13. And again, 13 times 8 is 104. Add 23 equals 127. Now, all of these so far, be careful, have added to bits at the end, but it doesn't always mean that's the case. Have a look at these two here. We've got 2q minus 7 equals 3, so there's our difference here, we're working with minus. But again, it's the same. We look at, on the way, we did 2 times by q, and then we subtracted 7 to get down to 3. So on the way back, again, we're going to do the opposite. We subtracted on the way. This time, we're going to add 7. So therefore, 3 add 7 takes us to 10. So we now know that 2q is 10. To find 1q, I'm going to have to halve it. 10 divided by 2, or 2 times what is 10. Either way, q is going to equal 5. And it's the same with this one here. 5y minus 11 equals 39. On the way back, let's do the opposite. We took away 11, so this time we're going to add 11 to it. 39 plus 11, either do it mentally or written method for addition. 39 add 11 is going to give me 50, so I know that 5y equals 50. To find 1y, then I need to split 50 into 5, or how many 5s go into 50. Luckily that's a nice easy one. I know that y is going to equal 10. So when you have a look at the problems that are on the sheet I've emailed out to all of your adults, the first sets of problems will be looking like this. Written calculations, where rather than using a bar model, we're going to be using this method to work forwards and then backwards to find out what our missing algebraic letter or symbol might be. The last few are starting to look at how we could put these into some word problems. Because, as we all know, questions aren't always just written as a calculation. This is a really, really common way of addressing the question. And this is algebra just hidden within a word problem. And it says, Jenny thinks of a number. She multiplies it by 4 and then adds 10. Her answer is 42. What was Jenny's number? So, ignoring the fact that Jenny's sitting there thinking of numbers, which is rather odd, let's have a look. So, we'll call it any letter we want. Let's call it J, because it's Jenny. What does she do first? She multiplies her number by 4. So we've got 4 lots of J. So J times 4, but remember algebra, we can just say 4J, and then it says she adds 10 to it, which gives her a total of 42. What we've now got is the exact same kind of equations we were looking at before. So on the way back, remember we're going to undo it all. So she added 10 last, so let's take away that 10. 42, take away 10 is 32. So we know that 4J is 32, but to only find 1J, we're going to do that 32 and we're going to split it into 4. So we know that J, 32 divided by 4, is 8. And again, I can just check that. 4 times 8, add 10, is 42. So exactly the same here, slightly unusual one here. Mrs. Freeman wins first prize in a limbo contest, of course. She doubles her money, but then she spends £25 of it on pick and mix, and she has £35 remaining. How much did Mrs. Freeman originally win? So to solve this question, we need to first of all think, what is this problem going to look like as an equation? So again, Mrs. Freeman, let's give her F as her symbol. Okay. She wins a certain amount of money. There's the F. She doubles it first of all. So we need to think, what does double mean? It means she's got 2 times it. So she's got 2F. However, she spends £25. So be careful. She's not added 25. She has spent £25. And her money remaining is 35. So that's what this problem looks like as a calculation. So when you're looking at these, think carefully how you're going to show it. So Mrs. Freeman's money, F, is doubled, so 2F. but then she spends £25 of it, so she's taken that £25 away and she's left with 35. So when I'm looking to find out how much money Mrs. Freeman originally won for her limbo contest, last thing she did to the 35 was to take it away, so we're going to add that £25 back on. 35 add 25 is £60. So we know that when she doubled it, we know that 2f equals 60. Therefore, on the way back, let's divide it. Half of 60, Mrs. Freeman must have originally won £30 for a limbo contest, which is a job well done. So, have a go at these problems. The first set are all going to be simple calculation kind of ones, and then at the end there's a few different word problems to see how you can start to apply your knowledge in them. If you've got any trouble, please do give me an email, or I've put the comment section onto YouTube so you can add a comment and I'll see it and I can then get back to you via that way if that's easier. But good luck, have a go, look forward to seeing how you get on.